So we have talked about the case where we have the vertical and horizontal asymptote. We also talk about the case where we have a discontinuous in our graph. Let's talk about the case where we have a slant asymptote. To find the slant asymptote, what we do is to start with the long division of the polynomial. Okay, so let's take a look at this in this case. To find the slant asymptote, we do the long division of x squared minus 1 into x to the third plus 2x. So x squared go into x to the third x times. We multiply it back to get x to the third plus 0x squared minus x, and then we subtract. Okay, so this becomes 0, 0 plus 3x. Now the function f of x is now become x plus 3x divided by x squared minus 1. So the slant asymptote is this equation. That is y equal x. So let's go ahead and sketch the graph of the slant asymptote. And I will make it in dashed line. Okay. So let's talk about the vertical asymptote. The function is f of x equal to x to the third plus 2x divided by x squared minus 1. The slant asymptote, we take the denominator, set it equal to 0. So then x equal to plus or minus 1. That is our vertical asymptote. So I go ahead and put this into our graph. So x equal negative 1. X equal 1. And here is y equal x. We will follow the same procedure to get the graph. So next we'll find the x and y intercept. So x-intercept is the value of x when y equal to 0. So when f of x equal to 0, x to the third plus 2x is equal to 0. So x squared plus 2 equal to 0. Then saying x is equal to 0, or x squared plus 2 equal to 0. So x squared plus 2 equal to 0 doesn't have a real solution. So then we only have the x-intercept at y equals 0 and x equals 0. For the y-intercept is the value of y when x equal to 0. So when x equal to 0, f of 0 is equal 0 in this case, so the y-intercept and the x-intercept is the same. Let's take a look at the behavior of the graph about the vertical asymptote. So f of x equal to x to the third plus 2x divided by x squared minus 1 can be factored as x times x squared plus 2 divided by x minus 1 times x plus 1. I will make a table. So here as x approach, As x approaches 1, negative 1 from the left, negative 1 from the right, 1 from the left, 1 from the right, and we have the factor x, x squared plus 2, x minus 1, x plus 1. Okay. As x approaches negative 1 from the left, here we get negative, negative, positive, positive, and here we get x squared, so it will be positive throughout. As x approaches negative 1 from the left, then x minus 1 becomes negative, 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 and positive, positive, excuse me, this is negative, positive, positive, and positive. So overall, f of x is approaching negative infinity here, positive, negative, and positive. Okay. So that's what we know so far. Now what we do is to make the table of value to determine what the graph would look like. Okay, so go ahead and make the table of value. Pick the value for x and calculate the value for f of x. I shall choose the value of x is to be negative 3, negative 2, negative 1. We know that we have a vertical asymptote. Okay. Negative a half. At 0, we got 0. A half. At 1, we get a vertical asymptote. 2 and 3. And we find this value and fill up the table. So these are the value. So let's plot this on the graph. Negative 2, 4. Negative 3, negative 4 point. Excuse me, negative 2, negative 4. Negative 3, negative 4.125. So let's get a gun on that. And so this graph looks kind of like this. Okay. 1/2, negative a half, you get to 1.5. 0, 0, 1/2, negative 1.5. So the middle doing this. And then the right hand side, 2, 4. 3, 4.125. So that is the graph of f of x equal x to the third plus 2x divided by x squared minus 1. So again, let's recap what we did. We find the slanted asymptote. We find the vertical asymptote. Then we go ahead and find the x and y intercept. Then we will determine the behavior of the vertical asymptote, of the graph around the vertical asymptote. Then we make the table of value and sketch the graph.